Okay, everybody. Sorry, getting sort of set up here. So the topic for today, as you can see up at the top, solving logarithmic equations with properties. So we've covered solving log equations. I'm going to review two problems. I'm actually going to do 1 and 2 as quick reviews, and then from there down will be the actual new stuff. And so we've been studying solving equations and we studied properties. The first way to solve equations is with a one-to-one property. If you have the same logarithm on both sides, they just cancel out. And then from there, you can solve using whatever algebra steps you already learned. 1a minus 4a is negative 3a, divide by negative 3, and you get your answer 1. And then you're supposed to plug that answer in to make sure it's not extraneous, make sure you don't get error on your calculator. I'll just tell you on this worksheet, that's not the main point, so I did not put any problems on this one that would have extraneous solutions. You're supposed to always plug your answer into a calculator and check. If you're taking like the ACT or your college entrance test and you got up to the point of logarithm problems, you would definitely check your answers for extraneous. But for now, the main point is to learn something other than that, so I'm not worrying about it yet. So anyway, that was a one-to-one. Then we had the types of problems where you can't just cross out logs on both sides. So you use other methods. Well, here, obviously, that's just a plain algebraic method. Subtract 8 on both sides. But then you cancel out a logarithm by dropping a base. Whatever the base here is, that's the base you drop, and you drop it on both sides. This cancels out. You get x equals 1 equals 5 to the 0 power. Of course, you're supposed to know anything to the 0 power always equals 1, but in case you didn't remember that, 5 to the 0 power is 1. And then you just add 1 to both sides, x equals 2. So that's a recap of kind of the two equation solving skills we've already focused on. Now we're getting to this type of a problem. So the logs are not on different sides. You can't cancel them out. Even if you moved one over to the other side, there'd be this extra term here that is not a logarithm that would prevent them from canceling out. So you can't really get the two logarithms on different sides of the equal sign and cancel them out. There's always going to be some other term to mess that up. Furthermore, there's reasons, but you can't drop a base to solve this because dropping a base is kind of a weird process. Drop a base is kind of a phrase that I kind of use. I don't know if I invented it or if I heard it somewhere just to explain how to do it, but it's not really what happens. And basically, if you try to do this, you're sort of using a distributive property on this dropping the base. You're dropping a base here and here, but it's just not the type of operation that distributes. So suffice it to say, when you have multiple logarithms in the same problem, you can't do the dropping the base thing. So what we can do is resort, whatever I want to say, to, in this case, the product property. When you have two logarithms that are added together, you can condense them. Now I'm writing this down as a note. You do not have to write the word condense on every one of your homework problems. I'm going to use the product property. Same thing here. You do not necessarily have to write product property next to your work. But basically, I can combine these two logarithms into one logarithm, log base 9, and it's going to be negative 3x times 4. When you use the product property, the two arguments get multiplied together, which means I have log base 9 of negative 12x equals 1. So by condensing, I went from having two logarithms to having one logarithm. Well, when you have one logarithm, then you can drop the base, and that cancels out. And you get negative 12x equals 9 to the first power. Hopefully you know 9 to the first power is 9 because anything to the first power just stays the same, but I did it on the calculator in case you wouldn't believe me. And from here you divide both sides by negative 12. Of course, negative 12 doesn't divide into 9, but you can reduce that by 3 to 3/4. If you wanted to use a calculator, so 9 divided by negative 12, and then hit the fraction button, and there's your negative 3/4. All right, let me scroll down to number 4 and check the answer. Yep, right there, negative 3/4. So we looked at expanding and condensing logarithms. The only thing you're going to worry about today is condensing. And then once you've done that, we'll do the, drop the base thing. So here, again, two logarithms and a minus sign. So if you remember from the properties from last week, subtraction, when we condense this, is going to involve the quotient rule. The quotient rule is where you combine these both into one logarithm, make a fraction bar. What's first goes on top. What's second goes on bottom. Now that you have one logarithm, it's sort of, I went back up here and I said you can't just drop the base right away, and, I didn't give it a good explanation. It's kind of an order of operations thing. You can't drop the base at first. It will not give you the right answer. But now that we have one logarithm, we can drop a base 5 to cancel out the log of 5. You get x plus 9 over 3 equals 5 to the first power. Of course, 5 to the first power is 5. And we need to solve this. To solve for x, since we have divide by 3, I'm going to multiply both sides by 3. Multiply and divide cancel out. X plus 9 equals 15. Subtract 9 on both sides. X equals 6. And what I could do, I'm not going to waste a lot of video time here. Let me make that 6 look more like a 6. What I could do, but I'm not going to waste the time, plug 6 in right here and work it out in the calculator, type this whole thing in, and see if I get 1 for an answer. Again, theoretically, you could get, undefined as an answer, which means there's no solution, but we'll just suffice with checking the answers down below as the only way to check right now, just to sort of save time and not worry about too many details. Okay, so number 8. How are we going to condense number 8? This is where, if it was a regular classroom, I'd give time and wait for someone to answer. But since we can't really do that, I'm sure you've talked to your iPad and you've said product property. This is a product. Again, you do not have to label product as the property you're using. I just am doing that. So it's going to be log 7 times x plus 2 equals 1. So the plus basically turns into times, and we condense from 2 logarithms to 1 logarithm. Now we drop a 4 on both sides to cancel this out. I'm going to erase that arrow. I'm left with 7 times x plus 2 equals 4. I can distribute the 7 in here. 7x plus 14 equals 4. Subtract 14 to the other side. 7x equals negative 10. Ooh, this is an ugly fraction. 7 won't divide into 10, so we leave it negative 10/7. Let me check number 8 and make sure that's right. Yep, right there. And look at these answers. They're all fractions. So I know sometimes a fractional answer can sort of leave you a little unsure or unsettled when you're doing your homework. Just expect that it's going to happen here. Okay, number 10. So if I want to condense these 2 logarithms into 1 logarithm, what do I do? What does the minus sign tell me to do? Okay, if you said quotient identity, you are right. 1 logarithm, in this case it's log base 2, put a fraction bar. The 9 goes on top, x plus 10 on bottom, and I have a 1 over here. Now what? If you said drop the base 2, you are correct. That cancels out. 9 over x plus 10 equals 2 to the first power. That's just 2. Now, how do you solve an equation like that? This is called a rational equation. And, if you're scratching your head over it, if you look confused, I don't blame you. You haven't done a lot of this, at least not recently. Maybe in Algebra 1 you did. But to solve this, basically, you just multiply both sides by x plus 10, rather. The x is in the denominator right here, and we certainly don't want it there. But because it's divided, you are allowed to multiply it on both sides, and it cancels out. Over here, you get 2x plus 20. And now it's a fairly basic looking equation that should not give you any trouble. Negative 11 equals 2x. Divide by 2. Of course, 2 doesn't divide into 11. So negative 11 halves should be the answer to number 10. Let me look. Right there, negative 11 halves. All right, so we're up to our last one. We're almost done. I just want to do a little summary here before I finish. We're not doing too much that's brand new. All right, we've solved logarithmic equations before, and we've done the properties before. Now they're just being combined into the same problem. So use the property to condense, and it's always going to be either a product or a quotient. You can work the power property in here, but it's not on this worksheet, so don't worry about it. So this one being minus is clearly going to be a quotient property. So you put your fraction bar. x plus 3 goes on top, x goes on bottom, equals log base 4 of 80. Now look at this one. We don't even have to drop the base here. We have the 1-to-1 property. The log base 4s just cancel each other out. X plus 3 over x equals 80. Multiply both sides by x, since the x is being divided, and it'll cancel there. You get x plus 3 equals 80x. Subtract x on both sides. 3 equals 79x. Divide by 79. 3/79. That seems like a weird answer, but there it is. So yeah, like I said, we're just combining skills we've already learned. How do you solve logarithmic equations? We covered that. How do you condense? Here I condensed with a quotient property. How do you condense logarithms? And we use the quotient or product property, no power property on this worksheet. So there you go. The homework problems are going to be very similar to the notes that are right next to them. So for this one, we'll probably do this for a couple of days till you get really good at it. But for now, it's just a matter of sort of following the notes as you do these. It should be very sort of a parallel situation, problem for problem. So go ahead and do the odds. Of course, submit questions to me under the normal means. Turn it in. And hope you have a great day, and hope you find this